A perfectly normal toilet, or so you'd think, but this one has the potential to start a revolution. The front part of this toilet is for urine. It's collected separately. Urine contains a whole host of nutrients, but also the residues of pharmaceutical products that can prove a problem for our waterways and the creatures that live in them. Flushing requires only a small amount of water. The urine arrives in a storage tank virtually undiluted. Under the leadership of the Danish scientist Tove Larsen, an interdisciplinary research team in Switzerland is investigating new methods of wastewater disposal.
Here at the Swiss Federal Institute for Environmental Science and Technology, we're working on a system where urine is stored in the house. At night, when the sewers are empty, the storage tanks in every house are opened and the urine flows away to the sewage treatment plant. Just before it reaches the sewage treatment plant, the urine is diverted and we can subject it to further processing.
At present, all household wastewater flows together to form a filthy sludge. In the sewage treatment plant, this is cleaned in a process involving several stages.
When the urine reaches the sewage treatment plant, it has already been diluted 200 to 300 times. By then, it's extremely difficult to extract either the nutrients or the hormones and residues of drugs from the sewage.
Instead of re-equipping the sewage treatment plants, the Institute wants to get to the source of the problem by using a new method.
For those involved in the business, it's a sensible approach for the future.
Recent research has shown that the residues of pharmaceutical products and hormonoactive substances that are left in treated wastewater can be harmful to fish. And current sewage treatment technology is not sufficient to remove these residues, because here we're dealing in micrograms.
By collecting urine separately, the intention is to break down specific harmful chemicals and at the same time to obtain valuable fertilizers. Untreated urine has an unpleasant smell due to the evaporation of ammonia. This is because of its high pH value.
If the urine is put into a bioreactor, the bacteria turns it all into a valuable recycled product in a matter of 2 or 3 days. Not only that, but the process gets rid of the estrogen, a hormone found in the contraceptive pill, for example, and which is a water pollutant. This liquid is now the raw material for fertilizer. The pH value has fallen.
In the small reactor, we've seen that the nitrogen has now formed compounds. It no longer has a bad smell and it no longer gives off ammonia. Secondly, we've seen that the estrogen has disappeared as a result of this process. We don't understand exactly what happens yet, but we can see that something has occurred and that in all probability it's a positive thing.
Various urine samples are being analyzed in the laboratory. They want to obtain a clear understanding of what is going on in the bioreactor.
Untreated urine is compared with samples from the bioreactor. Its composition has already been the subject of numerous studies. Both the nutrients and the residues of some pharmaceutical products are familiar, as is their approximate concentration. This allows the scientists to carry out specific tests and, in a further step, to take appropriate action.
Not only estrogen is exciting interest, the scientists are looking for other hormones and antibiotics that can be found in human urine, but which are not wanted in the urine fertilizer that is to be prepared later. The first results have come back for the estrogen, which cannot be completely removed from the wastewater mixture in the sewage treatment plant. In the untreated urine, there is a clear evidence of estrogen. Following processing in the bioreactor, on the other hand, the hormone has disappeared.
Separating the urine is now the first step. It's easy to imagine, though, that you could go further. Obviously, we also have feces, which also contain nutrients. Then we also have detergents from the washing machine and the dishwasher. It's quite possible that in time we will have technologies that we can put to good use at the source of the waste.
The general idea is to have separate waste disposal and to target specific waste products, not just for household rubbish but for liquid waste as well. Here, yeast cells that react with pollutants are added to a range of water samples. These bioindicators show whether the liquid in question contains any substances that are harmful to the environment. In the complex mixture that makes up the wastewater, individual substances are often hard to pinpoint and even harder to eliminate. Undiluted wastewater is far easier to deal with.
An enticing idea that is backed up by impressive initial tests. But it's still a long way from being put into practice, not least because it would mean saying goodbye to a system which, on the face of it, works very well.
I believe that those involved in the practical side of this business will sit up and take notice when they see that this type of measure is an effective solution to a water protection problem, better for the fish.
In this sense, the separation of urine could be another important step on the way to restoring our lakes and rivers to health.